Hello everyone, today we will be studying p-n junctions. A p-n junction is a junction between a p-type semiconductor and an n-type semiconductor. It exhibits diode behavior as the current flows only in one direction. It is a junction between a p-type semiconductor and an n-type semiconductor. Diode behavior is exhibited as the current flows only in one direction. So let us study the behavior of the p-n junction in zero bias. As we had learnt in the previous lecture that the p-type semiconductor has mobile holes and the n-type semiconductor has free electrons. The p-type semiconductor has mobile or free holes and the n-type semiconductor has free electrons. So what happens when we join them together and no bias is applied across them? Due to the high concentration of holes on p side, the holes diffuse from the p side to the n side. Similarly, due to the high concentration of electrons on the n side, the electrons diffuse from the n side to the p side. This results in a depletion of free carriers near the junction on both sides, resulting in the formation of a depletion region. So let us see how this happens. p-n junction so this is the p side and this is the n side. So the p side has mobile holes and the n side has mobile electrons. These are the holes and these are the electrons. Now, due to the high concentration of electrons on the n side, the electrons diffuse to the p side. Similarly, due to the high concentration of holes on the p side, the holes diffuse to the n side. Due to the diffusion of these free carriers, a depletion region is formed near the junction. This is the depletion region which is formed near the junction due to the diffusion of the free carriers. An internal electric field develops from the positive ions to the negative ions due to the formation in the depletion region. Due to the formation of the depletion region. So now, let us see here. This is the depletion region where the free carriers have been depleted. This is the width of the p side of the depletion region. This is the width of the n side of the depletion region. So now, let us look at some terminology and graph. This is the graph of the volume charge density. This is the volume charge density for the n-type layer and this is the volume charge density for the p-type layer. So where E is the electronic charge, Na is the acceptor doping density per unit volume and Nd is the donor doping density per unit volume and rho is the volume charge density. So, and it can be seen from Gauss's theorem that the electric field is varied by the charge density. So this is the Gauss's theorem. It can be seen that the electric field is varied by the charge density. And from this graph, it is also visible that the electric field is varied by the charge density. Also, the electric field is zero outside the depletion region with its peak at the center of the depletion region.